In this video, we are going to do an introduction to testing. So I just want to look at software testing in a very general sense, kind of get you feet wet, establish some baseline terminology, and talk about testing in general. So first off, why do we want to write tests? A lot of people complain that writing all these tests takes a lot of time. Why should we even bother doing it? Junior developers especially, they just want to get right into the meat and potatoes and write that code and bang it out and try to run it and make sure that's doing what it's doing. Some can put in print line statements to see what's going on. And that is definitely a junior developer type thing. The reason you write tests is it is going to improve your software quality overall. It absolutely will help the quality of your code. It proves that your code is going to be doing what you think it should be doing. So this is very important. And I've made mistakes. And it's so easy to use a greater than sign instead of a less than sign. Very, very, very easy mistake to do. So tests are going to catch that. So you're going to be testing conditions like that. The goal of having test coverage is you want to end the good old fix one thing and break another. So when I was more of a junior developer, all the time, I'm going to be absolutely honest there. All the time, you go in, fix one thing and break another, and then you're just chasing down bugs. And that is because I didn't have test coverage. When you have good test coverage, it's very easy to change one thing and then break a test and see the ramifications of your change further down the line. And this is really why it is widely accepted as an industry best practice is to have solid test coverage. As you get into larger shops, software development shops with more developers and more senior level developers, you will see that tests become more and more important. And it also allows you to change existing, and I put in there, working code with confidence. So as you develop software, it's very common for that software to evolve, business requirements to evolve, you to look at things and go, oh, this is probably a better way to do that. This is more efficient to do it this way. So having tests allows you to change existing and working code with confidence. Now let's talk about some testing terminology. Code under test. This is the specific code, or it could be an application that you are testing. A test fixture, this is right out of the JUnit documentation, is a test fixture is a fixed state of a set of objects used as a baseline for running tests. The purpose of a test fixture is to ensure that there will be a well-known and fixed environment which tests are run and repeatable. Now this can include input data, mock objects, loading a database with known data. So it basically sets up your test. So you have code under test and then a fixture, which is going to kind of set up the environment for your code to run within. Unit test or unit testing. This is something that is largely abused, I should say. People use unit test and quite often they're not talking about an actual unit test. So I want to be specific on this. This is code written to test code. So it is designed to test specific sections of code. Percentage of line code tested is code coverage. So this is another important term is code coverage. Ideally, your coverage should be in the 70 to 80% range. And I say ideally, there are some people that are very detail oriented. They want to have 100% coverage. And when you start getting above this, and this is a really ballpark figure, when you start getting above the 80% range, you start getting a diminishing value of returns on your test. So there's something very small, very minor. You may or may not want to spend time testing that, especially if it's something very obvious. So that's why I'm saying in the 70 to 80% range. And this is not a hard, fast rule. You could very easily say, hey, somebody said that it should be at least 85%. I'm not going to argue with that. So I'm just saying this is a very ballpark range. Your unit test should be unity. So they should be very, very small and execute very, very fast. And by this, they should be very targeted. They should be targeting a very specific thing. If they're going through and testing a lot of scenarios, you might want to take a step back and rethink things. Either your test is wrong or your code is wrong, one or the other. A unit test should not have external dependencies. And I said, i.e. there, no database, no Spring context. It shouldn't be talking to a web service. It shouldn't be talking to a message broker. Unit tests should be completely independent. I will say mock objects, I guess, are arguably okay, but definitely if you are bringing up an H2 in-memory database, that is, when you're doing something like that, you're getting into the realm of an integration test. These are designed to test behaviors between objects and parts of the overall system. So this is different from a unit test, which is usually going to be focused on a specific object, a method call within an object. That's what a unit test is going to be targeting, where an integration test is going to be testing behaviors between objects or maybe even multiple objects. So it is a larger scope. They are more complex. And now with integration tests, you can actually bring up the Spring context, bring up databases, message brokers, call web services, so that there's a lot more going on. This means that they are going to run much, much slower than unit tests. Now, functional tests is another area that's largely, I think, abused. And people do vary in terminology here. So some people call these a number of different things, but functional tests are primarily going to mean that you are testing a running, typically deployed application. So you might have a test environment that you've deployed to, and you're going to run the functional tests. So you're going to do, as I said, functional touch points. You might use a web driver to drive a web page. You might be calling web services from the deployed service. You might be sending and receiving messages from a broker. So functional tests are going to be a lot higher level that you're going to be testing. And obviously, since you've actually compiled everything and deployed to a known environment, they are very, very overall slow. So as far as speed, keep in mind, unit tests very fast, integration tests not as fast depending on what you're doing. And the slowest tests are going to be your functional tests. And this leads me up to the next thing that you need to be considering here is this testing pyramid. And you'll see this represented different ways. And the concept I want to convey here is the majority of your tests should be unit tests. So that's why I have the unit test down at the bottom of the pyramid. That should be your overwhelming majority. You want small, fast, lightweight tests. And I've seen a lot of people make mistakes on this, especially Spring developers. They are awful at this, to be honest. They bring up the Spring context for a lot of things they absolutely do not need it for. But what happens is that Spring context starts over and over and over. And when you start getting hundreds of tests, your test now goes from running in a few seconds to maybe a minute to 5-10 minutes. And it just slows down the build because you have a bad work practice. You're doing tests, but you're doing integration tests when you really don't need to be. So that's why I want to stress that you want very lightweight unit tests. They are very targeted. They are targeting very, very specific things. Now, integration tests, they do have their role. You do need to test interactions, but you're going to be testing at a much more granular level. So you're going to be testing interactions. You don't have to test every getter and setter in an integration test. That is not the appropriate place for an integration test. You're going to make sure that a message goes in and out. You have a unit test to test for all the properties getting set. And then finally, we get down to the functional test. These are the smallest in number, also typically the least detailed. So they're going to be, it's a service alive. I'm being a little sarcastic there, but they are going to be much less detailed than the other tests. It is more, some people do put details in there, especially for different web services. Sometimes they are just a sanity check to make sure that the service is up and returning back the minimal information. So different people have different philosophies around the functional test, but conceptually, what I like to see is most of the detailed business logic being tested inside of unit tests. Functional tests are going to have a much higher level. Integration tests are going to be somewhere in between. But the quantity of tests, the absolute bulk of them should be unit tests that are going to run fast. You should have hundreds, if not thousands, of unit tests and like dozens, hopefully less than 100 functional tests. So just to give you an idea. And there's no hard rules here. So it all depends on your application and its requirements. Now, the next thing I want to talk about is the importance of clean code. I hit on this, and if you join my email list, I actually have an email called, "But my 2,000 line method tested just fine." And I absolutely debunk that. That is absolutely impossible. First of all, and I've seen this way too many times, where a single Java method has over 2 lines of code, and it was absolutely obnoxious. And you can't test that properly. There are too many conditions happening within that. There's just too much stuff going on. within that single method that needs to be broken down, refactored into smaller, more manageable chunks. Now, my second bullet point there is quality code starts with quality code. And you need to be following good coding practices. I can't teach everything in this course. We are specifically on testing, not object-oriented programming or good patterns or anything like that. But you want to be doing the solid OOP, just good OOP in general. Gang of Board design patterns, you need to understand those. Excellent book. And I'll put this in the bonus section. I'll put a link up to Amazon there. Clean Code. It's an older book. It's by Robert Uncle Bob Martin. He's an iconic programmer, very smart guy. Really a lot of great tips in there. Like method shouldn't be more than a screen full. So if you're stringing it more than a screen full of code, you're probably doing too much in that single method. So just little rules of thumb like that, very pragmatic stuff. So it's an absolutely great book. If you're a newer developer, I cannot recommend that book enough. So my final bullet point there is test coverage cannot overcome poor coding practices. So think about going back up to that 2,000 line method, allegedly tested just fine. No, you cannot write a unit test that's going to cover everything there. So I want to talk a little bit about agile testing methods. Test-driven development, and we are going to see this coming up in the course. First, you write tests, and then you write code to fix the test, and then you refactor the code to clean it up, and then improve. So a very, very simple process. What this does, test-driven development actually gets you writing your test first. So you have a failing test, and then you go and implement it. So it makes you think a little bit more about what you're doing, what you're targeting with the test. And at the end of the process, you've already got the test written. So when you need to refactor something, you're good to go. We will also be looking at behavior-driven development. Now, this is very similar to test-driven development, and you can actually intermix them a little bit. And this is going to describe the expected behavior of software. So it's a little more expressive. I really like it. And when you're using the proper tools there, it's actually quite nice. I do like using Spock, which is a behavior-driven development framework, and it's quite nice. A lot of times you are going to express your BDD test as when, and then when blah, then I expect this. Or you could be saying, given a condition, when this happens, then I expect this result. So just having that logic there does help you visually structure your test better when you start thinking about how you're going to write the test. Now, which is better to use? I say use both. It depends on what you're testing. If you look at stuff that I write in a number of different languages. Sometimes it's depending on what I'm using, and I feel it's a better tool. Sometimes it's depending on my mood. I'm going to be honest there. But I do use those. And sometimes it's really depending on exactly what you're doing. So I don't have a hard rule of thumb there. Now, just a couple other things that we need to talk about because we will be seeing these in the course as well. Testing components, mocks. This can be a very confusing area. I'm not going to get into it too deep right now. A mock is a fake implementation of a class or an object that you're going to be using in a test. It is like a test double. Think about data source. So everybody taking this course should be a Java developer. So we've all seen a JDBC data source. A mock would be an implementation of that. So rather than getting a data source from MySQL using the jar for that to obtain a data source for it, I could write my own implementation of it and give back responses to my class that I'm expecting. So mocks can provide expected responses. They can also verify expected interactions. So a couple of important things about mocks. Now, spies, they are going to be like a mock, but a real object is used. And I kind of think the spies are more like wrappers. So they wrap up the real object. So you can say, I want to override something on this object with a spy. But at the same time, you can also say, we want to allow the normal behavior to occur. So spies are a little bit confusing, but the real object is involved. And we will be looking at both of these closer coming up in the course.